right, go and take out your textbooks, turn to page 239. Page 239. You did number 16 through 25 on this page. Practicing with area of different figures, and the homework had some rather unusual figures that required a little bit of creativity, perhaps to figure out. So let's go ahead and take a look at these, see how we did. Of course, the idea is to get these unusual figures into some form of rectangle. How do I find the area, class? Base times height. Square.
S squared.
Triangle.
1/2 BH.
Half BH. Parallelogram.
BH.
Or trapezoid.
1/2 H parentheses B1.
There we go. Okay, so you're trying to break it down into one of those. So on number 16 from the homework, we had this unusual looking figure, had 8 yards there, 10 yards there, comes across a little bit, comes down a little bit, goes over 7 yards, and then comes down 3 yards. Okay, not drawn to scale here on the chalkboard, I'm afraid. Well, what you'd want to be able to do is break it down into a smaller unit somehow. You could either draw this line, or both of them. Scott, which did you draw?
I did the horizontal.
You did the horizontal.
Both.
You did both. All right, so you know that this then is 3. You know that this piece then is 7, but if the whole thing is 10, Lana, that means this little piece is also 3, which means that this piece is 3. Now, if this whole thing is 8, and this piece is 3, and therefore this piece is 3, then Scott, this piece is 5. So then this piece is 5, so then this piece is 3. Okay, so you kind of figure out what all the little lengths are. Well, that would give us, Lana, if you do it your way, it gives you a square and 2 rectangles. This rectangle is 5 by 3. So that would be 15 square units. This is a 3 by 3 square.
9.
9 square units. And then here we have a 7 by 3 rectangle. 21 square units. And you add, or not square units, square yards. And you add all those together and you'd end up getting?
It's not right.
45.
Oh wait, it is right.
Yards squared should have been our answer. Now, Scott, in your case, you only drew the horizontal line. You still had to find 5 and 3, and 3 here, but instead of having to find the 7, you said this is a 10 by 3 rectangle, which gave you 30, and a 5 by 3, which is 15, which still gave you the 45 square yards. Okay, so both of you did have it correct. Is that right?
I got the same answer, but I put, I said that part was 4, but somehow I still got the same answer. So that part was 4 because that whole thing is 8.
Yeah, but this is 3 of the 8. It's not split half 50-50, is it? It's not cut in half. It's cut 3 here, 5 here. Somehow, though, you managed to get...
multiplied 7 by 3 because I thought that's the
Oh, okay. So correction, Lonnie. You did not do what you drew the lines, but then you ignored one of them. That's interesting. All right. So it didn't actually matter what you found that to be. Lana ended up actually drawing this line, and that's the only one you used. And you realized that was that up there labeled as 3? You found that because this is 7 and this is 10, that this up here is 3, because you said this is 8 by 3, which is 24. Then you said this is 7 by 3, which is 21, and that gave you 45. So you did end up with the correct answer despite having a wrong number written there. It didn't matter because you didn't use that number.
Yeah.
All right, let's take a look at the next one, where we had a 4 and a 5, and a long something, and a something, and a 6, and a 15, and a 35, and another 15. Well, if these are both 15s, then these heights match perfectly, correct? And if that's so, then this height also must match this height. So if this is 5 class, how about this piece right here? Well, we've got 4, we've got 6, but all the way across would be 35, right? So that leaves how much right here, Scott? 25. We could label there. Now, one way you could solve the problem, if by drawing this line, would be actually say the whole thing is 35 by 15. subtract away a 25 by 5. You could do it that way. Did anyone happen to do it that way? Okay, I didn't think so. Probably you drew a couple of lines like that. And you said, this is 4 by 5, Scott.
20.
You said, this is 6 by 5. 30. And you said, this is 35 by, how tall would that be, Scott? 10. The whole thing's 15, but you come down 5. So 35 by 10 is 350. And the whole thing has an area of?
400 meters squared.
400. They were meters, yes. So meters squared. Is that what you had?
Yeah, but I did it a different way.
Did it a different way. Did you draw vertical lines again?
I think so. I did.
Yes, you did.
Yeah.
All right, so Lana. No, that's okay, because it's the same figure, right? So as long as your numbers are right, it doesn't matter how you do it. Lana went down this way and said, this is 6 by 15, which was 90, I believe.
Mm-hmm.
And she drew a line down this way, which she said is 4 by 15, which is 60. Mm-hmm. And then you had to figure out 25 by 10, which is 250.
Yeah.
And then you add them all together, and of course it gives you the same area of 400 square meters. So good, some creativity in that. I like it. Looking at number 18, conveniently every box was just 1 unit, which is really nice, but a very unusual figure that looks something like this. Now, this is not a shape we recognize. It is a hexagon, actually. Right? 1, 2, 3, 4, 5, 6 sides. So it's a hexagon. Now, it's a concave hexagon. It has a reflex angle as one of its interior angles, which is why it looks so funny. But we can actually break this figure down into 2 different shapes by drawing one line. What 2 shapes did you break it into, Lana?
Triangle and a square.
A triangle and at least a rectangle. Yes, it is a square. It's a 4 by 4 square. The rectangle, now the area of the square is pretty easy, right, Lana? 4 by 4 square gives you an area of
16 units.
But with this triangle, now we know the area of a triangle is a half base times altitude, right? Which side, A, B, or C, did you call the base?
The longest one?
Right, you would have to look at it kind of sideways-ish here so that you could have your altitude here. So your base then is a total length of 6, and your altitude would be 4 more units, and you take half base times altitude, which ends up giving you an additional 12 square units to get an answer of?
28 square units.
28 square units. Is that what you had as well? Very good. Excellent questions on 18. Number 19 breaks it. It's a hexagon again, with again the reflex angle. But what 2 shapes did you break this into, Scott?
Parallelogram.
2 parallelograms. By the way, if you were to fold the parallelogram up, they would be congruent parallelograms, wouldn't they? Because they both have a base that is exactly 3 units, and they both have a height that is 2 units. The area of any parallelogram is base times height, so each parallelogram has an area of, oh, excuse me. Each box is 5. So it's not 3, class, it's
4.
15. It's not 2, it's 10. So each has a base of 15 and a height of 10, excuse me. And so the area of each individually is
150 square units.
And since there's 2 of them,
That's
300 square units.
Because I thought it was 4 across. Because it's like running into the 4th one.
Ah, well, if you look, did you draw this line right here, Lana? Did you draw the line? Okay. 1, 2, 3. Now, this end out here goes out to the 4th, but the base doesn't go that far, does it? The base itself, which would be this line, is only 3.
Oh, because I was looking 1, 2. I thought it was 4.
Right. No, from here, if you went from here all the way out to here, it would be. But here, that's again the best way to do it. Maybe take your pencil and do tick marks. There's 1 box, 2 box, 3 box.
Oh.
All right. So your answer would have been either at 20, 20.
I got 400.
20 by 10 is, yeah, you would have had 400 square units and just counted wrong on the baseline there. All right, but the process seems good. Number 20, what's the big, the whole, W-H-O-L-E, shape that we're dealing with here, Lana?
Trapezoid.
The big shape's a trapezoid, where the area of a trapezoid can be found using the formula.
A equals 1/2 h parentheses b1 plus b2.
And hopefully we counted correctly. What is the h, the height, the altitude of this trapezoid?
It was 6.
All right. The bottom base is how long?
Wait. 10.
Good. I'm getting 10 units. And the top base is?
8.
I don't have 8 units for my top base.
Oh, that's that one.
All right. What should it be, Scott? Count carefully. It's 6 units. And so the sum of the bases is 16. Let's take half the sum, Lana, should have given us
8.
8, and then 8 times 6 is?
48.
So the area of the trapezoid is 48. Sorry, slipping into high school geometry mode. The area of the whole thing is 48 square units. But we have 2 little holes we have to cut out, don't we? We've got a pair of little squares, and each square is
2 by 2.
2 by 2. So each square has what area?
4.
But there's 2 of them, so that's a total of
8.
8 square units we have to subtract. So our final answer should have been
40.
40 units squared should have been our area. To be honest, Lana, that's the reason I like the top pictures better than these gridded pictures, because you have to count over. So again, the trick is for this, again, starting here, this is the start. I don't say 1 yet, though. This is the start. 1, 2, 3, 4, 5, 6, and kind of count in that way. That way you get the correct measurement across. Number 21. Again, start with the big shape, Scott, which is a rectangle. Area of a rectangle, of course. And the base is
8.
And the height is 6. That's what I got as well. So I got the area of the rectangle to be 48 initially. But we've got 2 little triangles, don't we, that we have to subtract out. And each triangle has a base. If you turn the book sideways, each triangle has a base of
4
and a height of 3. So for each triangle, it's a half base times altitude. But there's 2 of them, right? So if I discount the half, that would give me the total area of both, wouldn't it? Which obviously is 12. Which if you subtract that away, leaves you with a shaded area of 36. It was 1. Okay, good. It was like 1 meter per thing. So 36 square meters is correct. First, like, oh no, did I need to double anything? No, 1 meter everywhere. Did you get the 36?
I got that one.
Excellent. Questions on this? All right, so a little bit more interesting than some of the other things. Now, number 22, they wanted you to find the perimeter of some shapes from this homework section. So going back to a problem that you did yesterday for homework, or a couple nights ago for homework, number 2, we had already found the area to be 240 square feet, but what did you get the perimeter to be, Lana?
64.
64 feet. How about problem 3? What was the perimeter, Scott?
31.2.
31.2 feet. How about number 16? What did you get the perimeter to be, Lana?
35.
Right, and that's because that jut down, remember you had called 4? When we had 3 here and 8 here, so 3 and should have been 5. So if you added 1 more, 36 would have been correct. 36 yards for number 16. And then problem 17, Scott? 110 meters is correct. You got 117 for that last one? All right, real quick on the last one, number 17, we had a 15. We had another 15 here. We came in 4, we came in 6, we came down 5, we came down 5. Found the gap to be 25, and then I have 35 here. So, let's see, those 2 add up to 60, those 2 add up to 30. That's 90, there's 10 more is 100, there's 10 more is 110. So 110 meters, what we should have had for the perimeter there on letter D. Number 23, determine if each pair of angles is complementary, supplementary, or neither. Letter A, Lana, 45 and 90?
Neither.
Neither. 80 and 10, Scott.
Complementary.
Complementary, 16 and 164, Lana.
Supplementary. What?
Supplementary is correct. You heard that too?
Yeah.
Very strange noise. I don't know where it came from. All right, we're being invaded by aliens, Joshua, but don't worry. If this video were to suddenly end, I'm just kidding. Anyway, I'm just being stupid. All right, number 24. Go ahead and read it for us, Lana.
The perimeter of a rectangle is 48 centimeters. If the base is 4 centimeters longer than the height, what are the base and height of the rectangle?
All right, so it's a perimeter, right? So what's the perimeter formula we need here?
I don't know.
Perimeter of a rectangle?
Oh,
That's area of a rectangle, perimeter of a rectangle.
2L plus 2.
There we go, yeah, you know it. And
Oh.
what do I plug in for the letter P, Lana?
The, what?
Are you reading number 24, Lana? You just read it aloud to me. What do I plug in for the letter P?
48.
Because that's the perimeter, very good. Yep. And do I know the length?
No.
No. Do I know the height or the width, if you will?
Yes.
I do.
It says the height right there.
Do I know what it is?
Yes.
What is it?
Oh, no, I don't.
No.
I'm not reading it right.
All right. All right, let me use letters they use. They use base and height instead of length and width, so let's go with B and H instead, okay?
That's why I was confused.
All right, so, well, you said 2L plus 2W. I was just writing down what you said. Because that's normally what we use, isn't it, Lana? But since they're using the terms base and height, okay, let's tweak it and say base and height just for them. Now, I don't know either one, though. I don't know the base. I don't know the height. In fact, that's what it asks. It says, what are the base and height? I don't know them. Which one does it all come back to, though, Lana?
The height.
The height. So I'm going to represent the height as
X.
X. What do I know about the base?
It's X plus 4.
Right, 4 centimeters longer, we're going to represent that X plus 4. And we should have used this equation here. Is this the equation that we had for number 24?
Sort of.
Sort of.
Pretty much.
Pretty much, okay. So then, we should have doubled the X plus 4. We have to distribute here, Scott.
I didn't do that.
Well, what should we have gotten if we distributed? Even if you didn't do it.
2x plus 8.
And of course, 2 times X is just
2x.
2X. We can combine the 2 X's together, Lana, to get
4X.
4X. And at the same time, let's subtract that 8 from both sides to get 40. And we'll end up getting X is equal class to 10. Now, X represents the what?
The height.
The height. So the height then must be 10 centimeters. The base was X plus 4. So if X is 10, 10 plus 4 gives us a base of 14 centimeters. And that should have been our answer. We have a 14 centimeter by 10 centimeter rectangle. Did we get that? No, okay.
No, I didn't.
Does it make sense now? All right, so even if you didn't get it last night, whatever, who cares? Does it make sense now? Okay. Number 25, Scott, read it for us.
A trapezoid has a height of 2 meters and an area of 32 square meters. If one base is 6 meters shorter than the other, what is the length of each base?
All right, it's a trapezoid, and it talks about area. So what formula should I write?
A equals 1/2 times H times B1 plus B2.
And let's say that base 1 is the short and base 2 is the long. Okay, now it doesn't really matter which one you call which, okay? But just for sake of knowing what we're doing on the board, base 1 is going to be the short one, base 2 is going to be the long one. What do I plug in for the A?
32.
In for the H?
2.
And then we come to the bases. And the question is, what's the length of each base? Because I don't know how long the bases are. But what does it tell me about the bases, Scott?
One is 6 meters shorter than the other.
One is 6 meters shorter than the other. The short is 6 meters shorter than the long, right? Is another way we could read that. So which base should be X?
2.
The long, right, should be x. How should it represent that the short is 6 meters shorter than x?
X minus 2.
6 meters shorter than x minus 6, right? And so this is how we should have set this up. So we've got 32 is equal to half of 2 times, and let's combine a little bit here. I've got an x and I've got another x would combine to give me 2x, negative 6. Now, very conveniently, the 1/2 end of the 2 class can simply cancel it, because if you think of this as 2 over 1, the 2's drop out, which is 1 over 1, which is 1, and 1 times anything is itself. So really, 32 equals 2x minus 6. To solve, I would need to class add 6 to both sides to get 38 equals 2x, and then x would simply equal 19 meters. Well, x was the long base, right? So that means the long base is 19 meters, and the short base was x minus 6, or 19 minus 6, or 13 meters. So the two bases, 13 meters and 19 meters is our answer. Did either of you have that? So we got this one correct. Do we see how this was very similar, but perimeter formula, not area formula? Questions on this? All right, well, let's go and turn the page, and let's talk now about a non-polygon. A circle. Why is a circle not a polygon, Lana? I thought polygons were closed figures. Because it's round, meaning it doesn't have any sides, because sides have to be straight lines, right? A circle isn't made up of straight lines. So a circle is not a polygon. Several important parts of the circle I want you to note there. First of all, the defining point of a circle is called the center. The center. This is where the circle really truly originates, is at this central point. And the idea of a circle is that every single point on the circle is what we call equidistant, meaning an equal distance away from the center. So if I drew this and said, is this a circle?
No.
No. How do I know? Because if you found a central point, this point is much closer than this point, right? This is little, this is big. To be a circle, every point would have to be the same distance. So I'd have to find that same distance there, 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 there. In fact, it would be best if I had a compass to get one set distance and just make that continuous distance around. That's the idea of how a compass is used to make the circle. So the center point is, of course, at the middle, and every single point is the same distance away. If I were to draw a line, let's pretend for a moment this is a little bit closer to a true circle. Pretend with me, okay? This distance from the circle, from the center rather, to any point on the circle, this line is called a radius. If you have one, it's a radius. However, if I draw lots of them, they would be referred to in the plural sense as radii. Say that with me. Radii. One radius, two radii. And what has to be true about all these radii you could draw in a circle, class? They have to all be equal, because every point is the same distance. That line kind of shows the distance, so yeah, all the radii would have to be equal. Now, if you were to draw a radius and then keep going and make another radius back to back, in a sense, you could think of it like a double radius. We have something called a diameter. Diameter starts and ends on the circle, but it goes through the center. This line is not a diameter. It starts and ends on the circle like a diameter, but it doesn't go through the center. A line like a diameter, but not passing through the center, is called a chord. A chord, C-H-O-R-D, note the spelling, not like a power chord, that's C-O-R-D. A chord, C-H-O-R-D, is just any line that starts and ends on the circle. Question, is a diameter a chord?
Yes.
It starts and ends on the circle, doesn't it? It's a very special chord. It's a chord that happens to go through the center. So there's a whole bunch of chords you can draw, but unless the chord goes through the center, it's not a diameter. Does that make sense? Question for you. What must be true? Well, first of all, how many diameters could I draw in a circle?
A lot.
A lot. More accurately, an infinite number, right? You could, as long as you keep starting on the circle, going through the center and ending on the circle, there's literally an infinite number of diameters you could draw. What would be true about all these diameters?
Equal.
They would have to be equal, wouldn't they? Because every diameter is equal to 2 radii. And based on what defines a circle, all radii have to be equal. And since all diameters are simply equal to 2 radii, if you keep adding equals together, you're going to continue to get equal sums, wouldn't you? So all these diameters are equal as well. Now the circle refers to, by the way, this curvy thing. This in here is not the circle, by the way. This mark on the board is the circle. Does that make sense? So this portion of a circle, this curved line, it's not a full circle, it's just a part of a circle. That's referred to as an arc. An arc, A-R-C. Now, A-R-K, that's like what Noah built, okay? A-R-C, an arc, is a limited portion of a circle. It's a part of a circle. It's just not a complete curve all the way around. Now, if you were to draw a diameter, and you were to start at one end point and take an arc all the way around to hit the next end point, you would have an arc that's exactly half a circle. I believe you know what we call that. A semicircle. Sorry, slipping into geometry mode. A semicircle. Now again, here's the thing. When you look in little kitty books, they shade all this in. They say, this is a semicircle. No. That is a semicircle. The semicircle is the actual curvy line itself. It's not all the stuff in here. It's just, that's technically, if you were to bind it this way, we have a segment that is half a circle, okay? But that's getting into something else entirely. But coming back here, so the semicircle is the arc that is half of a circle. Now, if I were to draw a couple of radii, I get a little angle right here. You see it? And because this angle's vertex is at the center of the circle, any angle formed by 2 radii of a circle is called a central angle. A central angle. You don't see that marked necessarily there on the picture, but you could draw it in if you wanted to. They have several central angles there. If you look at the picture, angle EOD, angle EOA, angle AOB, angle BOC, angle COD. They're all different central angles. Do you see that? Because they're all formed at the center by 2 radii. If you were to take the central angle, the radii, and the arc all together, this thing, it almost looks kind of like a triangle, doesn't it? Except it's a curvy piece. It's like a piece of pizza. Well, 2 straight lines with a curved arc, 2 radii with an arc, is referred to as a sector of a circle. A sector of a circle. Now, I used the term a moment ago, segment. That would be a straight line by itself. Finding it, you don't have to know that term in 8th grade. We teach that in 11th grade. We have a chord and an arc together. This forms a segment. A sector is formed by 2 radii and the arc between it. So anyway, a sector of a circle, that's not a term you're going to be tested on, but we will mention that term here in just a moment also. So several things that we see there. The point in the very middle class is called the center. Okay, a line from the center to the circle is called the radius. How many radii can you draw in a circle?
Infinite.
Infinite number. What's true about all the radii? All equal. What do we call a line that starts and ends on the circle? Chord. Good catch. If the chord goes through the center, it's called a diameter. What's true about all the diameters you could draw?
Infinitely many.
There's infinitely many, and they're all equal. What do we call any limited portion of a circle?
Wait.
An arc.
Oh.
A limited portion of a circle is called an arc. Now, an arc that's half a circle, Lana, is called a semicircle. Very good. An angle formed at the center by 2 radii is called a central angle. 2 radii, the area bounded by 2 radii and the arc between them is called a sector of a circle. The distance around a circle, you see that term in bold there next, is the circumference. The distance around a circle, sometimes called the perimeter of a circle, but we use perimeter for polygons. We use circumference to describe circles, but circumference is to a circle what perimeter is to a polygon. Okay, that's the distance around a circle. And interestingly, if you took any circle, you measured the distance around it, and divided that distance around by the length of the diameter, it would never quite work out perfectly. And again, to get perfect measurements would be hard anyway, but the ratio of circumference, I'm just going to abbreviate it this way, to diameter is constant. Every single circle is the exact same ratio of similitude. And it always equals 3.141592, so you get the idea. It equals pi. You need to know that pi is actually defined as the ratio of the circumference of a circle to its diameter. Pi is defined as the ratio of the circumference of a circle to its diameter. Now what's interesting is pi as a numeric value wasn't discovered, if you want to call it that, in its detailed decimal values until about 1,000, 1,500 years ago. But all the way back in Solomon's day, over 3,000 years ago, Solomon, as he was building the temple, God instructed his people, when you build for me the laver, make the bowl so that it has a length across this big and a distance around of 3 times as big. 3 times as big, that's approximately pi, very close approximation. So they had this idea that it's a little bit more than 3 times as much. Well, they came up with a value of 3.14159, blah, blah, blah. Now, unfortunately, that value is a little bit hard to use because it never ends and never repeats. It is an irrational number, right? Because the decimal never ends or repeats. For our purposes, we're going to say that pi is approximately equal to 3.14. We're just going to use those first 3 digits because the next digit is a 1 anyway, right? I mean, that definitely isn't rounding that 4 up. Or we could say it's approximately equal to 22 sevenths. 22 sevenths is like 3.1428, blah, blah, blah. This is 3.1415. I mean, by the time you're getting to the thousandths place, it's not going to make a big difference anyway. So any problem involving fractions or sevens, multiples of 7, this works really well. And then if you have decimal values, 3.14 works. So this gives us a couple choices of which value of pi we want to use. We're going to use pi then in calculating the circumference of a circle, because let's face it, you look at a typical ball, pipe, anything round, we always think of how big it is across. Even Scott's head, all right? It's not perfectly round, but it's okay. Scott's head is about, let's just say, 8 inches wide. You can look and guesstimate that. There's no way I could look at this and say, oh yes, it appears to be about this big around. Not without a tape measure, right? You don't look at a piece of PVC pipe and say, oh, this piece of PVC pipe looks like it's X many inches around. Nobody does that. You look at it and say, oh, it looks like it's about 1.5 inches across or 2 inches across or whatever, right? In fact, that's even how when you buy PVC pipe, it measures it that way, this big across, because that's how we think. That's how our brain works. So if we wanted to find a distance around, you would multiply pi times the distance across, or that diameter. In the event you were given a radius, how does the diameter relate to the radius again? Twice as big, right? 1 diameter is equal to 2 radii. So we could also say circumference is equal to pi times twice the radius. But remember, from our algebra segment, we always put numeric coefficients first, literal coefficients last. So here are your equations for finding circumference of a circle. C equals pi times diameter, or 2 times pi times the radius. It's up to you which value of pi you use. And again, you'll pick which equation you want based on whether you're given a diameter or a radius. Look at the example problems. They give you a radius of 4 inches. Well, since they gave them a radius, we use C equals 2 pi r. We plug in the 2. We plug in approximately 3.14 for pi. Notice the equal sign changed to a squiggly equal sign right there. And we plug in the 4. You multiply it out. By the way, I always multiply pi last because I don't like decimals. So 2 times 4 comes first. That's 8. Do the easy part first. Then suck it up and do the hard part. 8 times the 3.14 gives us to approximately 25.12 inches in circumference. Make sense? Question?
Can you just memorize 6.28 is...
You could use that as well. Yeah, I mean 6.28 is pretty easy. And then 4 times 6.28 would work as well. Good question. Look at the next one. They give you a diameter of 7/8 inches. Wait, 7/8? Well, if that's a fraction, I'm going to go with a fraction, right? Now again, it's approximate. Also, they give me a diameter, so I'm going to go with c equals pi d. We'll plug in the 22/7 for the pi and the 7/8 for the diameter. You'll notice in the book the 7s conveniently cancel. The 2 cancels out of both 22 and 8 to give you 11 and 4, so approximately 2 3/4 inches. Questions on circumference. We remember this from years past. Look at the next page. If you were to break a circle down into tiny little sectors, and you were to take these little sectors, almost like little triangles, and you were to line them all up like you see in the picture there, the circumference, half of it would be across the top, half the circumference would be across the bottom. The height, if you will, would approximately equal, well, would have to actually equal the radius of the circle, because each point is where you'd have the center and then the distance there, so the height would be the radius. Well, since circumference is 2 pi r, half circumference would be pi r, and the height being r, area of a parallelogram would be base times height. This is how we would extrapolate out the area of a circle. Area of a circle, then, is pi r squared. Though I've heard it said by other people who are not mathematicians that pi r not squared, pi r round, cake r squared. But for our purposes, for the area of a circle, we'll use the formula. I know, it's a dumb joke, and Lana's looking at me like, what? Pi r round,
Yeah,
pi r never squared, cake r squared, pi r round. But pi r squared when you're finding the area of the circle. All right, so anyway, look at the next example problems. Radius of 8 feet. Great. We plug in the 8, we square it, we get 64. We multiply 64 times approximately 3.14 to get approximately 200.96 square feet, or feet squared, because it's area. What if you're given a diameter? Well, you better cut it in half then, right? 14 cut in half is 7. Wait, 7? Ooh, I'm not going to use 3.14. I'm going to use 22/7, because that's easier, right? So notice they use 22/7 times 7 squared. Notice you, by order of operations, square the 7 first. Powers before multiplication, right? So 49, then the 49 cancels with the 7 to give you a 7. You get approximately 154 kilometers squared. Do we see how to use the area formulas? Questions on area or circumference? Any questions on those? All right. Let's go quickly over some things real quick. What do we call the vertex, or what is the vertex of any central angle class? The center of the circle. What's a chord that passes through the center? Diameter. Line from the center to a point. You don't have to write these in. Line from the center to any point on the circle. Radius. Arc equal to half a circle. Semicircle. Good. Distance around a circle. Circumference. Ratio of circumference to the diameter of any circle.
Wait.
What's the ratio of circumference to diameter?
Oh, pi.
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 Ratio of circumference to diameter is pi. Number 7. By the way, my dad sent me a meme last night, actually. This is pure coincidence. He had no idea this lesson was coming up. But he's like, I just got a snake that is exactly 3.14 meters long. It's a python. And I said, actually, it would only be a python if it was approximately 3.14 meters long. He's like, nerd. But it's true. Exactly 3.14 is not pi. Approximately 3.14 is pi. And so the writer of the meme clearly did not understand mathematics. Anyway, but it was a nice try. Number 7. I'm just a jerk. It spoil is fun, I know. Number 7. What are 2 formulas to find the circumference of a circle, Lana?
Pi and 2 pi r.
Good. This isn't in there. What's the formula for area? Scott?
Pi
r squared, you liar. Number 8. If a circle has a diameter of 10 feet, what's the radius, class?
5 feet.
5 feet. If a circle has a radius of 10 feet, what's its diameter?
20 feet.
20 feet. Very good. Do numbers 10 through 15, finding the circumference. They want you to use 3.14, not 22/7, which on one of these is a real bummer. Find the circumference of each circle using 3.14 for pi. I know, number 12, you're like, but it would be so much easier. I know. In fact, technically, if you're smart, even number 11 would have been easier with 22/7. because 3.5 is 7 halves, and that 7 could have canceled, but no, they had to ruin it. Actually, for sake of time, just do let's just do the evens, 10, 12, 14. Just do the evens, 10, 12, 14. So page 242, 10, 12, 14. Let's take a look at these together. Number 10, what did you get for your answer, Lana?
18.84 decimeters.
Good, approximately 18.84 decimeters. Number 12, Scott.
Approximately 43.88 inches.
Oh.
I got approximately 43.96.
Should be approximately 43.96 inches. Careful there. Double to get to 14, multiply 14 by, or 6.28 times 7, but just be careful with your multiplication. And number 14 for redemption, Scott.
Approximately 28.26 millimeters.
Good, approximately 28.26 millimeters. Questions on finding circumference? All right, now let's find the area using approximately 3.14. Let's do 16, 18, 20. 16, 18, 20, finding area now. So instead of pi d or 2 pi r, pi r squared. let's go and take a look at these. And number 16, what did you get for the area of the circle, Lana?
78.5 inches squared.
Good, approximately 78.5 square inches. Number 18, Scott?
15.1976 centimeters.
Oh. What do we have to do when they give you a diameter of 2.2 centimeters? We've got to divide it by 2 to get a radius of 1.1 centimeters, which you have to then square, right? For r squared, 11 squared would be,
1.21.
right, 121, but 2 decimal places would be 1.21 centimeters squared. Good job on the mental math. Then that has to be multiplied by the 3.14. Lana, what did you get for your answer on number 18?
I got 1,519.76.
No, not that big.
I think it's this basically.
The same thing he got, but you forgot your decimal points. Should have been 3.7994 centimeters squared. And back to Scott for redemption on number 20. A diameter
No, I just didn't think.
of 0.8 meters should have given us a radius of,
Oh, I think I got it
class.
right. 50.24.
Well, but you have 2 decimal places
Oh, I mean,
and
0.5024.
0.5024 meters squared should have been the answer there on number 20. Do number 23. Let's do number 23 next. Number 23. Both circumference and area, you're given a diameter of 10 yards. Do number 23. Finding both circumference and area. You're loud. Show you a trick. See how quiet that is? I'm just kidding. You can find something constructive and studying to do, maybe. That would be quieter. Your brain wheels turning is probably going to be quieter than that pen going back and forth. You are allowed to let them turn, though. I'm not saying not to let them turn. Whenever you want. Now is fine. All right, the circumference should have been really easy, Lana.
31.4 yards.
Yeah, because you just move the decimal one place and you're done with the circumference. The area, on the other hand, Scott, you had to first of all find the radius
5.
and then square it
25.
times pi.
78.5.
There we go.
Oh, yeah.
So a circumference of approximately 31.4 yards and an area of approximately 78.5 yards squared. All right, questions on 23.
I just copied 16.
Huh?
Ah, smart. Kidneys. All right, now that's just smart, right? If they're going to get
I just did all the work.
Well, those who are smarter sometimes get out of work. If you didn't catch that, Josh, Scott was like, number 16 has a radius of 5. This is a radius of 5. Why would I redo all that math when I already did it once?
That's why it took me so long.
Yep. Hey, I used to do the same kind of thing. So, you know. Let's drop down to number 26. Go and read this for us, Lana.
A circle has a circumference of 314 feet. Find the area.
Circle has a circumference of 314 feet. Find the area. How can I go from circumference to area? Well, what one value can be used to find circumference or area?
Pi? Wait.
Well, pi is used, but also the radius, right? So if I remember that c equals 2 pi r, I could find r. And then once I have it, I could plug it in right here, couldn't I? So, first of all, they said the circumference was what, Lana?
314 feet.
Stay with me. 2 times, for pi we're going to put in approximately,
3.1.
times the radius, right? Well, let's start here. Let's start by dividing away the 3.14 for a change. To get 2r, move the decimal twice, Lana, what would 31,400 divided by 314 equal?
100?
100. And if 2r equals 100, then r equals?
50.
So apparently, my 314-foot circumference circle has a radius of 50 feet. We can then plug in the 50 here, square it, Scott. Double the 0 is what you square the 5, but you also square the 0. There we go, 2,500 times 3.14. But you know what I ain't gonna do? I ain't gonna have 3.14. I'm gonna have 314 times a 25, which we just did. No, we didn't. We didn't. Never mind. We had 314 times 25. Kind of did in a way. There's a shortcut here. Think about number 23. Except there's 2 fewer decimal places. So tack on the 2 decimal places.
Wait.
7,850. All right, we just got 78.5, but with the 2 decimal places gone, that makes it 7,850 feet squared? Feet squared. So you got to cheat the system a little bit on that one. But do you see how you can actually go from circumference to area? Find the radius, and then use the radius to get the area. Anyway, homework for this evening or for the weekend is to do page 243, numbers 1 through 15. Page 243, numbers 1 through 15. All right, you are dismissed. Have a wonderful weekend. Enjoy the extra day off.